Hi friends, my name is Pratyasha. Today we will be learning how to compare fractions. In the previous video we learned what fractions are and how to represent those fractions using different models. If you haven't already visited that video, please go through that. So we will be covering how to compare fractions using 3 different methods using models, and I will also tell an easy way to compare fractions without using models. So let's get started. So the first type of example that we're going to take a look at today is different numerators but the same denominators. So let's take a look at some fraction that we can use to compare. So let's say 1 by 5 and 4 by 5. Here both the denominators are same and the numerators are different. So this type of comparison is comparing with different numerators but the same denominators. So let's use models to represent these fractions easily and understand them easily. So since we have the denominator 5, let's divide this model into 5 equal parts. So here, let's say that this model represents 1 by 5. It represents 1 by 5. And since it's 1 by 5, we have to take out 1 part from 5 parts. So we trade in 1 part. Let's say that we have to also divide this model into 5 equal parts. So here, let's say that 4 by 5 represents this model. So we have 4 by 5. And since we're saying 4 by 5, it's 4 parts out of 5 parts. So we shade in 1 part, 2 part, 3 part, and 4 part. So here we can notice which part is the larger part. So here we can say that this part is larger than this part. And since this part represents 4 by 5 and this part represents 1 by 5, we can say that 4 by 5 is larger than 1 by 5. So here the rule is that if you have the same denominator while you're comparing, you just look at the numerator and just compare. And whichever numerator is the larger numerator, you have to take that fraction as the larger fraction. So if we did that with this one, since we have the same denominator, the numerator 1 and 4, here if we compare it, 4 is the larger fraction, so since 4 is the numerator of 4 by 5, 4 by 5 is the larger fraction, and we ended up with the same answer. So now let's take a look at other types of comparisons. So the second type of example that we're going to take a look at today is comparing fractions with the same numerators but different denominators. So let's take an example. For example, 3 by 5 and 3 by 4. Here let's use models again to represent these fractions and understand them easily. So let's say that this model will represent 3 by 5. So it will represent 3 by 5. So since we have a denominator of 5, let's divide this equally into 5 equal parts. Okay, so here we have 5 equal parts, and we said that this model will represent 3 by 5. So 3 by 5 is 3 parts out of 5 equal parts. So 1, 2, and 3. Now let's say that 3 by 4 will represent this model. So 3 by 4. So since 4 is our denominator, let's divide this model into 4 equal parts. So 1, 2, 3, and 4. So since we said 3 by 4 will represent this model, let's take out 3 parts out of 4 parts. So 1, 2, and 3. Here we can notice that 3 by 4 is a larger fraction than 3 by 5 because this part is bigger than this part, and this part represents 3 by 4 and this part represents 3 by 5. So 3 by 4 is larger than 3 by 5. So here the rule is that if you're comparing fractions with the same numerators but the different denominators, then you have to look at the denominator, the fraction that has the smallest denominator, and that is the larger fraction. So here, since these two fractions have the same numerator but different denominators, 5 and 4 is a smaller denominator, 3 by 4 is the larger fraction. So let's take a look at other examples. So the third type of comparison is comparing fractions with different numerators and different denominators. So let's take an example. 2 by 3 and 4 by 5. Okay, so here, both the numerator and the denominator of both fractions are different. So here what we have to do, let's use models again to understand and represent both of these fractions. So let's say 2 by 3 is represented by this model. So 2 by 3, and we have 3 equal parts. And since we said 2 by 3, it's 2 parts taken out of a whole of 3 parts. So 1 and 2. So now, let's say 4 by 5 is represented by this model. Here we have 5 equal parts. And since we said 4 by 5, it's 4 parts out of a total of 5 parts. So 1, 2, 3, and 4. Here we can actually see which fraction is the larger fraction. So this fraction is larger than this fraction. And since this fraction represents 4 by 5, and this fraction represents 2 by 3, 4 by 5 is larger than 2 by 3. So this is a way that we can represent and easily compare the two fractions using models. But we can also compare the fractions without using models like this. So since both the fractions don't have the same denominator, we need to make the denominator same. And we do that by finding each of the denominators multiple. So the least common multiple. So for example, let's do 3, the multiple of 3, and the multiples of 5. Let's start with 3. So 3, 6, 9, 12, 15, and so on. Let's do the same for the multiples of 5. So we have 5, 10, 15, 20, and so on. So here, now we need to find out which of these multiples are both same in the multiples of 3 and in the multiples of 5. So here we have 15 and 15. So 15 is our common multiple. So if you had many common multiples, for example, other numbers that are just like the same kind, like 15, 15, so on, then what you would do is the same way, but you would take the least common one. So here, if we had even going so on, it would be 15 still because it's the least common multiple. So here 15 is our denominator that we are going to multiply together. So here, let's make the denominator same for 2 by 3 first. So we're going to have 2 by 3. And here we have to find out which number multiplied to 3 equals our least common multiple, which is 15. So here, 3 multiplied to 5 equals 15. So to 3, we have to multiply 5. And since we do it to the denominator, whatever we do to the denominator, we have to do to the numerator. So since we did multiply 5 to the denominator, we have to also multiply 5 to the numerator. So here we would get 10 by 15. And 15 is now our denominator. So now let's do the same for 4 by 5. So here, what multiplied to 5 equals 15? Well, 5 multiplied to 3 equals 15. So here we'll multiply 3, and since we have to do it to the numerator, we're going to again multiply 3, and we're going to get 12 by 15. So here we have both the denominators now same, and there are least common multiply, which is a denominator of 15. So now we can compare them normally by just checking the numerator. So we have 12 by 15 and 10 by 15. Since 12 is larger than 10, 12 by 15 is the larger fraction. So here we found out which fraction is bigger from 10 by 15 and 12 by 15. And since 12 by 15 is representing 4 by 5 at an equivalent fraction, 4 by 5 is our greater fraction. And it was the same answer using models too. So today we learned how to compare fractions in 3 different ways. I also told a way using models but without using models also. So hope you liked this video. Thank you for watching and bye!